The last part of these two sections is called something called the residual. So the residual is a number that shows how the y value is paired data compared to the predicted value. So essentially what this concept of residual is, you want to see, like, if we talk about money, let's talk about money and let's say, for example, movies. So I'm pretty sure a lot of people probably saw the movie Avengers Endgame, right, when it came to it. So it was one of the biggest movies possible, right? Made millions, $1 billion when it comes to it. Now the question is, well, residual means is, well, if I have a prediction, so I want to say, okay, I think I'm assuming it's going to be this portion, right? And it comes out even higher. So the residual means I have a positive, meaning if it's above it, meaning I actually made money in this scenario. So if the residual is a bigger or positive number, therefore we made money. However, if let's suppose they wanted, if we wanted $5 billion, but only came in $4 billion, so which means residual is negative. So if you subtract them, which means you made less money or you lost money essentially, right? When it comes to it, that's kind of what the residual is all about. It's just a value that shows you if you either made or lost money, depending on the situation. But that's kind of how the situation comes into play. And of course, it goes into more depth, but that's the best way I can figure out when it comes to money wise is obviously losing or gaining money depending on what you want. Okay, so the question is, right, if the residual is positive, then the y value is above average, meaning you made or farther than you actually thought it would be. Okay, on these super rare occasions, if its residual is zero, the y value is literally average. Okay, and if the residual is a negative number, then the y value is below average. Okay. So again, above average, talk about, when it comes to it, below average, again, very rarely will this ever happen. So it's going to be, a plus or minus number itself. And the residual is always the y minus y hat, or in other words, the observed value minus the predicted value. Okay, that's where we're going to find the residual. And we'll talk about that in a little bit more detail. So notice I give you guys a lot of information, very little very little questions. Now we're getting into in the bulk, so putting all this stuff together. Okay, so we're going to do question 5 pretty slowly, and then we'll do the other ones a little bit quickly so you guys get the understanding of what's happening here. So question 5 says, the number of men studying the Roman Catholic Church priests in the graduate level programs in the United States for various years are listed in the table below. Let Y represent the number of men in the thousands studying the priests in the graduate program. So they tell us what Y is. So this is about Y, right? The number of graduates in there. And let X represent the years. So this is going to be our X variable. Okay, that's going to be very important when we get, when we go do regression lines, right? We want to figure out what X and Y is respectively. So next thing we say is find the linear correlation coefficient. We find that, so they gave us the linear correlation coefficient is negative 0.9095. So we just go to 3 decimal places. We can do that since it's just a 0. So 0.905. Question A says, does the variables have a negative or positive linear relationship? Well, we got to figure that, right? So there's two things, plus or minus, so it's negative. Right? So that's it. Next up, B, do the variables have a strong or weak relationship? Well, since this is closer to -1, this is a strong relationship. Right, when it comes to it. And then the last part, C, is given S of Y is this and X of X is that, find the line of best fit or find the regression line. So those are the questions we did later, right? So first we got to do is find our slope, which is B1, so that's R, so negative 0.905 times S of Y, which is not S of Y, 1.754 divided by S of X, which is 12.72. So our B1 should be approximately negative 0.125. Okay, and then we go on, so we keep going, so we find our slope, or our y-intercept. So find these, find the mean of those respectively, right, when it comes to it. And I did this already, so it should be roughly 252.187. Okay. So therefore, our regression line is going to look like 252.187 minus, because there's a negative, 0.125x. Okay. So there's our regression line for part C. Now here's the thing you got to move more closely with D and E. It says, what is the slope and what does it mean? What is the y-intercept and what does that mean? So remember, going back to slope, right? It represents two things with the change of the slope. So first off, here is our slope, right? And we know it's negative, so therefore it's a negative relationship, right? But what has a negative relationship? So we go over here. So it looks like as the years increase, right, years are increasing, what happens to the number of graduates? They decrease. So what our slope is saying is for every year, the number of graduates decrease because it's negative, right? Decrease because it's negative by 0.125. Okay? So that's our slope. And the y-intercept is this value here. Now, what does this represent? So remember, the y-intercept in algebra is 0, comma, this number here. So what they're saying is at year 0, we had a maximum of 256. So essentially at year 0, so at year 0, so the first year it opened, we had, so they had 250.108, in this case it's thousands, right? Well, we'll just say that number of graduates. Okay. Now let's look at E. So E says, use your model to predict the number of men studying in the Roman Catholic Church in the graduate level programs in 2009. Okay. So let's look over here. So notice 2009 is not on our list. So what this is saying is, using our regression line, we want to predict how many graduates we would have in 2009. Meaning, if x equals 2009, what is y hat going to equal? So now this is a basic algebra problem, right? Plug and chug. Plug in 2009 into the equation and see what we get out. So let's see what we get. So it's going to be, let's see. So 252.187 minus 0.25 times 2009 gives us approximately 1.062 thousand graduates in this case, right? And that's how we do predictions. You literally just plug in the x value and see what we get out for the y value, right? So predictions. Okay, so hopefully that wasn't too bad, right? We're going to go through it. A little bit of review from the last portion, and this is, a little more in depth when it comes to slope and everything like that. Okay, let's try the next ones. So, one more. F says, use your model to predict the number of men studying in 2030. So essentially, we're going to do the exact same thing we did above. We're going to plug in x being 2030, and then see what we get. So, use a calculator. So you get y is equal to negative 1.56. So essentially, you have no people, right? So you can't have negative value, but that's pretty much where you would predict. There will be no people or no men in the Roman Catholic priest graduate levels at that point. Probably not going to be realistic, but according to our data, that's going to be it, right? So just going back into the plug-in chug stuff. Okay. All right. So hopefully that wasn't too bad. So let's try example 6 now. A little more in-depth one. Okay. So question 6 is using the Starbucks regression line. So they give us the regression line, right? It says using the Starbucks regression equation to complete the table, and then label the signed distances from the observed, i.e. actual number of Starbucks stores to the predicted number of stores. 2 rows are completed for you. So they told us that they gave us the regression line already, and they actually did. It's right here. Number of Starbucks stores equals negative 1106 plus 488 times number of years. Okay. Now, notice they didn't tell you what x and y was, but they did here. According to our equation, right? Our equation for the regression line is this. So 2 rows are completed for you. 2 rows are completed for you. Okay. Now, notice they didn't tell you what x and y was, but they did here. According to our equation, right? Our equation for the regression line is this. According to our equation for the regression line is this. right? So we know what x and y has to be. So x is always next to the slope, which means it's going to be the number of years. So it's going to be that. It's going to be our x. And since this is number of Starbucks stores, this is going to be our y values. Okay? So they don't have to literally tell you what x and y is. They can give you the regression line, and from there, you should be able to tell which is x and y just from that portion itself. Okay? So now we have this regression line. If you want to make it easier, I'll write down right up here. It's y hat is equal to negative 1106 plus 480x. You want to think of x and y itself. Okay? So now it tells us find the signed distances from the observed. So that's essentially what they're asking is find the residual. So what we have to do first is find the predicted number of stores. And they said they did 2 already for us, right? So what they did is they literally plugged in this value into our observed and see what we got out. So what happens when you plug in 84 in for x? I mean, sorry, 0 in for x. Okay, so if you plug in 0 in for x, you get negative 1106. Okay. You plug in 1 in for x, and we'll just keep going down the list, right? We were predicting what they should have itself. So negative 1106 plus 480 gives you negative 618. And we keep going. So next one is negative 1106 plus 288 times 2 give you negative 30. And notice it's kind of following the template down here. Right, so this line of estimate's already done for us. It's kind of pop, 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 and eventually we get positive. So if we plug in 3 now into our equation, you get 388, and we just keep going. So I'll just go a little bit faster. Okay, so if we got those ones, they weren't too bad, right? It's literally just plugging in for x into the equation. You get these out. Now, remember the residual now, it says you subtract the observed minus predicted. Now, predicted is your y hat. So in the equation, it is y minus y hat. Observed minus predicted. So you're literally going to subtract straight across. So you can do 84 minus a negative 1106, which should give you positive 1190. And we do the same thing for the rest of them. So 116 minus a negative 618 gives you positive 734. And we keep going in that same template. So now notice now it becomes a little bit smaller, right? You started huge. Now once we subtract, we're subtracting 2 positive numbers, so we're not going to get any bigger from now on. So believe it or not, this actually becomes a negative, right? 86, and we keep going. Okay, that one's done for us there, and we keep going. So notice it kind of follows the same template, right? Notice these are beneath the line. So these are negative residuals. So notice, and these are positive because they're above the line. And that kind of makes sense so far, right? The first three are positive. All the other ones are negative because they're below the line. And notice now, at this point, we should get a little bit higher than the line just by that. So you can tell, right, when subtracting now, you get positive numbers instead of always negative numbers. Okay? So once we have those, what's the whole point of the residual? Like for this question, I talked about money before, but I'm going to give you guys a more specific example. So here's a specific example, right? So this is the number of Starbucks stores, right? And this is the number of years since 1990. So they opened, right? So in 1990, they opened 84, right? And they predicted minus. So they actually predicted less than stores. They got a positive, meaning they made good money, right? They put more stores out there than they expected to happen. And notice in year two, so in year one after that, and keep going, they made good money, right? So they made more positive stores than they're actually losing now. But notice after 3, 4, 5, 6, 7, right, the number of stores they predicted to get was actually less than that. So something could have happened. It could be like they lost money in that portion, but a lot of stuff explains what's that happening here. So a lot of companies figure out what's happening here, or why do we make profit, or go with our predicted values itself. So these numbers here should be roughly the same here, because or even better, because what that's saying is we have far more Starbucks stores than what we predicted, meaning they're making more money. So here, however, they weren't expanding as much as they wanted until they got to a cusp, right? So after year 11, after 1990, then definitely they blew up, right? So it was a 400, so, and then 1,000, and a little bit less, but so forth down the line. So at that point is, well, they could say, okay, now that we got our bearings, well, maybe we could add more stores. Our predicted value was far less than we expected, right? We made, more money, or they made more stores than they actually happened. And this goes on to twisting, right? You can do this in the future, like we call them predictions, right? So here's a little fun fact, right? Let's suppose in year 20, going with this template, right? We want to see what is our predicted number of Starbucks stores we will actually have. Because remember, we don't have the actual observed. So using our portion, right, we're just going to plug in 20 into our portion here and see what actually happens, right? So in 20 years after 1990, how many Starbucks stores do you expect this company expect to actually pop up? So they expect about 8,654.